Today we are going to talk about why do toilets only have an exhaust fan but no fresh air supply? If you look at toilets, you'll notice one thing. There is always an exhaust fan, but there is no duct supplying clean air directly inside. In this video, I'll explain the real engineering reason behind this in a simple way with some technical concepts. In the building, ventilation system is installed to remove hot air from electrical equipment rooms. When the equipment operates, the electrical panels generate heat, warming and moving the air around them. To control this temperature rise, a fresh air fan brings in cooler outside air, while an exhaust fan pushes the hot air out. This cycle continues until the room temperature reaches the required design level. Toilets have ventilation fans to maintain fresh air, but their design is usually exhaust only. The fan removes stale air from the toilet, while no fresh air duct is directly. Toilets are considered dirty zones in HVAC design. This means the air inside may have germs and odors. According to ASHRAE, indoor air is classified based on its quality. Air with low contaminants and inoffensive odors is classified as Class 1. Toilet air is classified as Class 3, which means it cannot be recirculated to any other area. Class 1. This type of air can be recirculated or transferred to other spaces. This is why toilet exhaust must go directly outside, ensuring contaminants and odors don't spread. Let's start with the basic science of airflow. Air always moves from a high-pressure area to a low-pressure area. Just like water naturally flows downhill and moves into any free space it can find. Air also travels toward the area with the lowest pressure. When one side of a space has higher air density, meaning more air molecules packed into that area, the pressure becomes higher there. The other side has lower density, so the pressure is lower. Because nature tries to balance pressure, the air moves from the high-pressure side toward the low-pressure side. This flow continues until the pressure becomes equal on both sides. This is the key principle behind ventilation, exhaust systems, and all HVAC air movement. When the fan starts running, the impeller pushes air from one side to the other. This action creates negative pressure on the suction side and positive pressure on the discharge side. That pressure difference is what makes the air move through the system. If we supply fresh air only in a toilet area, that space becomes positively pressurized. When the pressure increases, the air will naturally start moving into the nearest space around it. When designing toilet ventilation with both fresh air and exhaust fans, the exhaust air flow must always be higher than the fresh air supply. This ensures the toilet stays under negative pressure and prevents air and odors from escaping to other spaces. But if the exhaust fan fails or stops running, the fresh air fan will push air out into other areas which we don't want. So the correct design is to rely on the exhaust fan to pull air from the toilet through the door louver. This keeps the toilet under negative pressure and prevents air from escaping to other spaces. Let's calculate the toilet airflow for this size. ASHRAE recommends 10 air changes per hour for toilets. For a toilet that is 10 meters long, 10 meters wide and 2.3 m high. To find the room volume, multiply the length, width and height. The result 250 cubic meters. This tells us how much air the space can hold. This means the entire volume of air in the toilet must be replaced 10 times every hour. So the required ventilation rate is 250 cubic meters times 10. 2500 cmh. This is the minimum exhaust airflow needed to meet the standard. If the ceiling height is more than 2.5 meters, the air change rate should still be calculated based on ceiling height. For toilets that are heavily used, such as public toilets, we should follow the National Environment Agency recommendation. NEA advises that the ventilation system must provide a minimum of 20 air changes per hour. I hope this explanation helps you understand the engineering behind a simple toilet exhaust fan.